Hello and welcome to Into the Terminal. Today's episode 19 is about updating your system. So let's jump right on in. So we're looking at a Red Hat Enterprise Linux 8.5 system that has some outstanding updates available for it. So if you're interested in applying all updates to a system, DNF update. It'll go out to Red Hat, get the metadata from the Red Hat Enterprise Linux repository, and then compare that with the installed packages on your system to pull up this list of available updates. And it is pretty expansive. We can see at the bottom it's 76 upgrade packages and 3 to be installed packages. So you just hit yes, and then it would start downloading and applying these updates. But I want to work on some finer grain updates as well, so I'm going to say no to this. All right, so if you're not interested in applying all updates, but you're interested in applying a specific update. So notice in here we have our TZ data, time zone data, was available. So we can do a DNF update TZ data. And now that we've provided an individual package argument, or more, if you wanted to group more packages on that command line, it goes out and processes the update transaction. So I'm going to say yes to this one. So it downloads it from the Red Hat content distribution network and then applies it to the system, and we're done. All right, the third critical command that I'd like to offer is if you're interested in applying security related updates only. So if you do a DNF update -- security, I'm going to go out to the repository data and pull down the packages that are related to CVEs. Those are critical vulnerability and exploits that are published for Red Hat Enterprise Linux. So if I apply these 30 packages, it'll go ahead and install them on the system. These are the security related updates. All right, let's transition into the second part of the show where we can take a deeper look at some of these practices. All right, so in the second part of the show, this is where we spend a little bit more time looking at our task at hand, in this case, applying updates to a system. This is also a time where you can put in some questions in chat, and I will pay attention to chat and answer them. Or if you're watching in a deferred mode, you can put those questions in the comments, and either Eric or myself will answer them. Also, don't forget to like if you enjoy this content so that we will continue to make more of it. And if you think that there's someone else that you know that would enjoy the content or could get value from it, please share it with them. All right, so let's take a deeper look at updates here. So one of the things I wanted to pull back up is our DNF security update. And of particular note in this transaction list, at the very top, it says installing. And then that's different than upgrading. And down at the bottom in the transaction summary, notice it says it's installing 3 packages, but updating 30 packages. All right, so what's going on there? Typically, when we upgrade packages, we're looking for something that has the same package name, but a newer version number. And if there is a package available with the same name, but a newer version number or a larger version number, then that's treated as an update. However, kernels are special because kernels you can have multiple installed at the same time. The reason you're able to do that is because kernels are kept in a segregated namespace so that version-specific information is applied to all the kernel's files, or at least the directories in which kernel's files live, and that ensures that there's no conflict between files being provided by different packages, even though they have the same name. So let me say no to this, and we can look in lib modules as an example. So this is where the kernel puts its modular kernel content, and you can see that there's 2 directories, each with their own version number. If we look in /boot, where the kernel puts its binary monolithic component. You could see that the VM Linux files that are the compressed kernel files that get loaded at boot time, they also have unique version components, as do things like their initial RAM disk and their config and their system map. And so all these files are able to be kept separate, which is why when we do a kernel update, we install it rather than upgrade it. And DNF and Yum are smart enough to know that when it's operating on a kernel RPM, it should install it and not upgrade it. There's no special handling required on the part of you, the administrator. All right, so let's apply that kernel update. Yum update kernel. All right, so it recaps my um, transaction here. I'm going to say yes. And what we'll see is that there's a new VM Linux with the new kernel version number and boot. There's a new modules directory and libmodules. But at this point, this installed new kernel is just files on a disk. It's not actually my system kernel. Because in order to complete your kernel update, you need to reboot your machine and boot into that new kernel so it's the one loaded in memory and running all the operations on your system. All right, so let's give it just a second to finish up, and then we'll take a look at some of that configuration. All right, good morning, Eighth Doctor. Again, now's a great time to ask any questions that you've had up until this point, or things you'd like to see me cover later in the show. All right, so in libmodules, I had two kernels installed before. Now I've got three. In boot, I had two VM Linux for individual kernels. Now I have three. Right, and we can see by the version number that this is the newest one because it has the highest numbered version. All right, Eighth Doctor asks a great leading question about not rebooting the kernel. There is a new technology that we can use that I'll show you in a bit on how to avoid that, at least temporarily, right? But in order to run this kernel and have it load into memory, traditionally we have to boot the machine to it so that it is now loaded in memory and operating the system as a whole. All right, we can see that it's not currently the one I'm running by using the uname command. I'm just going to use -R to show me the kernel release. So I'm running this kernel currently on the machine, which corresponds to one of the three that's installed. All right, depending on your file system layout, kernels may also introduce another interesting conundrum. So on some file systems or some system layouts, people create a boot file system that's separate from the rest of their disk storage. And there's a lot of reasons why that might be the case. But that means that there's a finite amount of space in /boot, which is where these VM Linux files and other kernel related files get dropped. So if I do an ls-lh on boot, all right, we can see that these compressed kernel images are the largest of the files that are stored. Actually, they're not. The init ramfs is the largest file stored here, but together with its mated kernel, it's about 40 megabytes. And depending on how old your partition layout scheme is, like a gajillion years ago, we recommended people have 100 megabytes of boot file system space. And 100 megabytes of boot file system space wouldn't get us very far these days. So it's often also the case that you might need to do some pruning of your installed kernels to make sure that you have enough space in /boot to accommodate new updates. All right, so here's the situation we're in. I am currently running this kernel, and I have two other update kernels installed on the machine. But this one, maybe I don't need it anymore. Not currently running it, so it's not the operational environment for the system. And then also it's been replaced by the newer kernel that I just installed as an update. So maybe that's a good candidate for removing. So if we want to remove a kernel, we can do a DNF remove. But we can't just say kernel because there's three of them. In fact, we do a DNF list. right? There's three of them installed on the box. So we can't just do a DNF remove kernel because it's going to choose one and it might not be the right one. Instead, we have to also provide the version number of the kernel we're trying to get rid of, which is this string right here. And I've always found that copy and paste is my friend here. Typing it by hand is a little bit more tedious and prone to error. All right, so let me go ahead and remove that one that I'm not using. Right, we can see it's been removed from the machine. And if I look in boot, those files that were there that were about 40 megabytes of space aren't there either. So that's how you clean up kernels that you need to remove, is by specifying the version number along with the fact that you want to remove the kernel package. All right. So let's take a look at what else I have on my deeper dive list. I see there's some questions, and I'll get to those in just a second. All right. So the next thing on my list is kernel live patching. That will address one of Eighth Doctor's questions. Um, The default for RHEL is to have a separate boot, isn't it? If you take the default file system layout, yes. So if you don't do any partition changes through the installer, it will create a separate slash boot. I don't recall the size of that off the top of my head. But if we look at the installation episode from 2 weeks ago, I bet it's in there. Shuntanu asks, does RHEL ship with something equivalent of auto remove to cleanly remove all older kernels? Once boot into the last kernel, of course. Um, so kernels are handled a little bit special. I don't know that we have an auto remove for kernels specifically. There is some mechanism in DNF to remove things that are no longer in use. So things like they're installed for dependencies, but now the package that they were installed for doesn't exist anymore. That kind of stuff does get cleaned up with some of the DNS auto remove options. I don't think that applies to kernels because they are so specially handled on our system. All right, it looks like Eighth Doctor says DNF will automatically maintain a sliding window of the three latest kernels by default. So something to be aware of. Um, this system, I only had three, or I got up to three, so we didn't get to see that in place. All right, so Eighth Doctor had asked a question earlier about maintaining your kernel without rebooting. So there are a couple of technologies out there that will allow you to apply an update to your running kernel in memory. And one of those technologies is provided as part of Red Hat Enterprise Linux, and it's called Kpatch. Now, what Kpatch does is we can create a live kernel patch that will circumvent system calls and libraries used by the kernel that have been replaced with updated versions to alleviate some CVE mitigation. So, to say this a little bit more bluntly, if your system has a kernel that is susceptible to a critical or important security CVE, Red Hat will provide a kernel live patch for it if we can. So a kernel live patch will put this new framework into place that will allow the kernel to bypass its old calls and instead use newer updated kernels. So the reason I'm running my oldest kernel in this environment is so that I can show you kernel live patching. So if I do, first I need to install the Kpatch application. That'll allow me to manage the kernel live patches that I can install in the system. And now that I have it installed, I can do a kpatch list. And we haven't done anything with kernel live patches yet, so it shouldn't be a surprise that the modules that are loaded in my kernel, there are none. But this kernel is pretty old. It was the original kernel shipped with RHEL 8.5, and I know for a fact that there have been some live kernel patches made available for 8.5 since then that will update some of its modular content to allow them to be bypassed in RAM. So I'm going to do a DNF list kpatch-patch. So we ship kernel live patches as RPMs because they're a file archive, and then we do some stuff to load their content into memory after it's been installed on the system. So there's a bunch of kpatch patches out there. Oh, let's try that again. DNF list available. Oh no, I wrote it. I need a star because I need the version numbers too. All right, so here are all of the K patches that are available for this system, or that Red Hat has put into the CDN. Not all of them are available for this system. Notice that one of the things in the kernel patches RPM name is the version of the kernel for which it was produced. So I'm not running kernel 4.18.0-193.19.1. I'm running kernel 4.18.0-348. So I'm interested in ones that have this version number in them. All right, we produce more K patches over time. Each one is a roll up of the previous. So you can't just like cherry pick one out of the middle and go, that's the one I want. Or I'm only interested in this update to a K patch. You take the whole package or none of the package. All right, and then to apply it, we have a DNF install. And we're going to use a little bit of scriptiness to get the right one. All right, so I'm going to install a kpatch patch RPM. The one I want is the version equal to the uname -r value for this kernel, right? So that's what we just saw up here on the output of uname -r. Remember in our shell scripting episode, we talked about running these quoted execution or commands that will resolve before their larger command that holds them is executed. So essentially, it's substituting the version number of my currently running kernel into this DNF install command for me. All right. So here's the kpatch patch we're going to install. It is for my currently running kernel. And then the version information over here tells me about the rollup of kpatches that have been done for this kernel. So that extra version for kpatches not only tells me in the package name what kernel it's for, but the version information tells me more metadata about what's contained in that patch set. Okay, so this is a file archive. It gets unpacked on the local directory tree. So all of the file content is there. And then the kpatch executable that we installed earlier will take that file content and load it to memory. And it uses a mechanism, forgetting the exact name for it. It's something like no. I'll have to look it up. But there's a built into the kernel mechanism through which this data that we just loaded in memory can be used instead of another piece of data that came with the kernel. And so it's essentially operating as a bypass. Additionally, the kpatch service has been set up so that if we reboot the machine, we'll get our old kernel with kpatches loaded for it at boot time or during the boot process. So if we have a reboot by accident, we'll still be running the kpatches in memory, and those obsoleted or CVE vulnerable calls will still be bypassed by the installed kpatch. All right, to show you that it's there, we can kpatch list. Right, there's the one that's installed and loaded. So you can have more than one installed because maybe you've maintained your kpatches over time and installed more than one. But the loaded modules, this is what's actually in the kernel right now, and is your list of bypasses. All right, so that's a little on kpatch. Kpatch is meant to be a stopgap from needing to take an emergency downtime to replace your kernel. So if it were me and I was maintaining this system, I would do two things when I'm maintaining the kernel updates, especially security ones. One is I'd pull down any K-patches that remediate that security issue now. And then two, I'd install the updated kernel so that at my next maintenance window, I can reboot the machine and reboot it into updated kernel. So K-patches are there to kind of get you to your next scheduled maintenance without needing to take a reboot to boot into an updated kernel because of some security vulnerability that has been remediated. All right. So I see a little bit of chat about Tony Harris added some additional context around how we keep kernels. Thanks for that, Tony. That additional detail is great. And then I see some content from 8th Doctor about the size of /boot by default if you take the defaults as part of their install. Great work, guys. Thanks. All right, so we talked about K-patches. Since we're talking about K-patches and the fact that they're remediating security things, maybe we're interested in knowing what security things have been remediated by these K-patches. So if we use a RPM query against the K-patch package that we installed, we can look at its changelog, and the CVEs that are remediated by a K-patch are listed there. So RPM is a command that we've not looked at before. It is actually what's called under the covers by DNF and Yum for doing the package-specific operations of installing and upgrading. Excuse me. So we can do things like query a package, and maybe I'm interested in querying its changelog information. And let me scroll up to my list of K-patches here and just copy and paste this complete RPM package name from my transaction. And we'll send that to less so we can see the topmost changes, the most recent changes first. So this is what has happened in the most recent K-patch that I just applied. Specifically, these CVEs over here are the ones that are mitigated by applying this K-patch. And presumably, if I was to install the updated kernel, those CVEs would also be updated in that installed kernel as well. All right, we can see that there are, I mentioned earlier that the K-patch is a roll-up of previous K-patches. So the previous version of K-patches for my kernel included a couple of other CVEs that were mitigated, and the version before that included this CVE that was mitigated. So when I installed this one, I got all those previous CVEs remediated as well. All right. Cool. So that's a lot on K-patches. Let's do a couple other small things. So one is maybe you're interested in getting your updates pre-staged before you have a maintenance window. So if I do a DNF update dash dash download only, oops, helps if you spell update correctly. So download only says don't install the updates, just download them to the cache of the machine. And so if you're operating in a maintenance window, you have a certain period of time that you have to get all your maintenance done in. So if you can save time by downloading these packages first, and then when you go and do a DNF update, it's just doing the installation piece, that might help you have an easier maintenance window so that you're not up against the time that you've allocated towards the maintenance. Plus, if something were going to go wrong, you have a little bit of extra time inside your maintenance window to try and troubleshoot and diagnose that. All right, so this was a tip from Eric, who unfortunately couldn't be with us today. But he used to do this across his population just prior to his maintenance window so that he could ease some of the time burden in his maintenance window. All right, the last thing I wanted to include is automatic updates. So there's varying degrees of people's comfort level with automatic updates. Personally, I am not a fan of automatic updates. Automatic updates are executed against a time So when you install it, you actually get a system timer that determines how frequently we check for updates to apply them. The reason I don't like automatic updates is because it introduces new changes to the system in a schedule that I don't necessarily know. Right? When I'm working off something like a maintenance window, I know exactly when the changes are being pushed to this machine, and I can look at things like the DNF transaction history and see exactly what those changes are. So if during my maintenance something isn't right, I know the course of events that have occurred that have gone from a system that was working just fine to a system that is now having problems. And that helps me diagnose and revert things to get back to that known good state, or resolve problems that may have been introduced. But with automatic updates, they're happening in the middle of the night, at random times of day, or I should say on random days, not necessarily during that allocated maintenance period. So that's why personally I don't like automatic updates, especially for my production systems. For my workstation, I do, however, have them installed because they're small changes, so the likelihood of them causing problems in something like a lightly used workstation is relatively minor. But I want to keep up to date on my workstation as much as possible without having to go through the rigor and structure of maintenance windows. But on those critical application servers that I maintain, that's where I want to have that extra piece of awareness of what's happening at the system at which times. All right, if you're interested in automatic updates, DNF install DNF automatic. So this will install the DNF automatic package, which gets you things like your system timers, and now your system will be at least enabled for automatic updates. All right. Looks great. Don't see any new questions. Eighth Doctor says you can also configure DNF automatic to pre-cache updates that you can apply later. Great. That might keep us from needing to pre-stage that in a very bulk fashion prior to maintenance releases. But yeah, so another option for doing updates. The last thing I want to talk about is security advisories. So in our K-patch, for example, we saw the CVE numbers listed for CVEs that K-patch closed. One of the best things I think about Red Hat and Red Hat Enterprise Linux products is our product security team. They do a fantastic job on stuff. So I wanted to show you the security advisories portal that we maintain for Red Hat products. So these are all the security advisories that have been issued for Red Hat Enterprise. Actually, this is for all products, so let me change it to just Red Hat Enterprise Linux. Right, so you can select the product you want. You can even say, oh, I'm only interested in version 8, or maybe even a dot release like 8.4. And maybe I'm only interested in x86 64 related because I don't need security remediations for power systems because they're not as a part of my fleet. All right, so these are all the Red Hat security advisories that have been issued. You can see that they're also rated from low to critical, and each of those is assigned a score. So the ones that Red Hat takes a lot of effort in updating are those that are tagged important or critical by their scoring mechanism. So why don't we just take a look at the criticals here? And we can see that there's a critical Firefox security update that was released on March 10th, 2022. And if I select the advisory, it gives me a bunch of description about what it is and what products are affected and how we manage the updates, and then what CVEs, critical vulnerability and exploit numbers, go along with this security advisory. Right? CVEs are maintained by a neutral party to track vulnerabilities and exploits available in software products. All right, but we're interested in Red Hat stuff. So I'm going to look at Updated Packages tab. And these are the versions of packages I'd be interested in order to remediate the CVEs listed in this security advisory. So this is how we kind of go from CVE number to package that we install to remediate against it. Also, let me take a look at the overview here. CVEs have a criticality I mentioned. So let me look at one of them. So each CVE is graded. This grade is assigned first by by an industry panel that assigns gradings. It's called CVSS. But then the Red Hat product security team actually takes a second pass at the grading because it turns out that based off of Red Hat's configuration or additional technologies like SE Linux, we may not be as vulnerable to this CVE as other systems may be. So this score that's displayed here is actually the Red Hat adjusted score for the CVE. And why that's important is that Red Hat produces a feed of all of the vulnerabilities and all of their Red Hat adjusted scores that security scanners can use when addressing outstanding CVEs for systems. And so it might be that if you're using a security scanner that does not account for Red Hat's prioritization changes or scoring changes, you might be sent a report that says you have a critical vulnerability, but when you go and you look at Red Hat site, it's ranked as a moderate or a low. And that's why, because Red Hat looks at the actual details of the CVE compared with our code base of stuff that we use and ship in our products to more refine what that score might be for Red Hat specific technologies. All right. So we kind of ran the gamut today on some ways that we can update our systems, some different technologies like Kpatch that we can use for changing how we maintain systems, and then delved a little bit into security updates and what those look like and how we manage them. All right, so thanks for joining me today on Into the Terminal. Tonight will be our last weekly or last daily episode of dark mode. Today was our last daily episode of Into the Terminal daylight mode. We will transition into a weekly cadence from here on out. So next week on Thursday will be our next episode, episode 20, which is going to be a little bit more in shell scripting. So we're going to cover things like control structures with ifs or conditionals and looping mechanisms, specifically for loops. And then we'll be going weekly from there on. We will continue to do a morning show at 10 a.m. Eastern and an evening show, dark mode, at 9 p.m. Eastern, but changing the cadence to once a week because that's much more sustainable for Eric and myself. All right, well, we'll see you next time. Thanks, everybody.